Exponent laws. So we learned these a long time ago in grade 8, grade 9, reviewed them in grade 10 and 11. When the bases are the same and you're multiplying, you add exponents. Make sure you're comfortable with exponent form, either going from left to right or from right to left. A to the power of x minus y means you've got a to the x divided by a to the y. I think when we first taught you this, we started here and went this way. Be comfortable going that way as well. A to the power of x to the y is a to the x times y. When you have a power to a power, you multiply exponents. And when you've got more than one factor being raised to a power, that power applies to both of the factors. Okay, so taking what we know about exponential functions, can you apply transformations to this one? So we're starting with that. We all know what y equals 2 to the x looks like. It's exponential growth. The base is bigger than 1. It has a y-intercept at 0, 1. So this is just the graph, a quick sketch. Put it in your notes. Y equals 2 to the x. You should be able to label two other points on there really easily. What would happen if x were 1? 2. And if x were negative 1? A half. Okay, so everything you remember about transformations, verbal description of the transformations, this compared to that. Well, I think in Math 12 we did this. We would have written it in this format, so it would be a little bit easier for us to identify that outside the function, we've got this plus 3, which moves it 3 up. That is going to take our horizontal asymptote, which was at 0, and move it 3 up so that it is now at 3. New horizontal asymptote. What does this negative do to the function? Y goes to minus y. I reflect it in the x-axis. When you get a reflection over the x-axis, everything flips upside down. So you should think about this graph as being oriented this way. Can we see it? Okay, do you remember how to do a mapping to get it to reflect in the x-axis and shift 3 up? What would happen to any point xy on this original graph under these transformations? Do we change anything with the x inside the function? Do I do anything to the x? So x is going to stay the same. What about y? Well, what did I do? I had to change the sign, and I want to move it 3 up. That's what's going to happen to all your points. So let's go and change these all. Let's start with 0, 1, our intercept. X is 0, still 0. What happens to the 1? It becomes a negative 1 plus 3. Gives me 2. So x is 0, y is 2. So there's where the intercept went to. Remember, it's going to look this way. So we're expecting that. Okay, let's try the point x is 1, y is 2. So if x is 1, we still got 1. Y is 2. I would have negative 2 plus 3, which would give me 1. And x is negative 1. I still have negative 1. And I would get negative a half plus 3, which would, I guess, give me 2.5. So x is negative 1, y is 1, 2.5. And we should see our graph looking something like this. So look at our transformed graph. Let me turn this off.